Hello everyone, hope you all are doing well. So in this video we'll discuss the second problem of Leetcode Weekly Contest 338. Okay, it's a medium level problem. The accuracy is again on the lower side. Let's see why. So the problem name is prime subtraction operation. So you are given a zero indexed integer array nums of length n. Okay, you can perform the following operation as many times as you want. Now what is that operation? Pick an index I that you haven't picked before. Okay, and pick a prime number strictly less than nums of I. Then subtract p from nums of I. Okay, return true if you can make nums a strictly increasing array using the above operation, and false otherwise. Okay, a strictly increasing array is an array whose elements is strictly greater than preceding element. Okay, so like for example, I have 4, 9, 6 and 10. So what I can do, I can pick up an index that I haven't picked till now. Okay, and I can subtract the strictly, I can subtract a prime number that is strictly less than nums of I. Like for, and my target is to make the given array strictly increasing array. Okay, strictly increasing, meaning the adjacent elements are such that the ith element is less than I plus 1th element. Simple. That's what we need to do. So if from 4, what is the largest prime number I can subtract? I can subtract 3, so this guy becomes 1. What about 9? I can subtract 7, this guy becomes 2. Here, just see, I can subtract 5, but if I subtract 5, I get 1. So this array is not strictly increasing. What is the other option? I can subtract 3. If I subtract 3, then I get 3. Okay, 6 minus 3 is 3. Similarly, from 10, I can subtract 7. But if I subtract 7, I get 3. So 1, 2, 3, 3 is not strictly increasing. So instead of subtracting 7, you subtract 5. So you get 5 here. So your final array is 1, 2, 3, 5, and this is strictly increasing. So you turn true. That yes, I can do this operation any number of times and basically form a strictly increasing array. Okay, similarly here 6, 8, 11 and 12. Now this array is already strictly increasing, hence you do not need to do any operation and you can return true, right? So yeah, if I look into the constraints, that nums.length is less than equal to 1000 and nums of I is 1000. So very, I would say constraints are on the lower side. So if I talk about the logic here, okay, if I talk about the logic, so if I want to make an array strictly increasing, okay, then a greedy approach will be that 4, 9, 6, 10, right? You try to make this element as small as possible, okay. So suppose I have made this element as 1. Okay, I've subtracted the largest possible prime value, so this is 1. Now if this is 1, then this guy can have a minimum value of 2. Okay, this guy can have a minimum value of 2. So what is the scope? How much can I subtract? The current value is 9, the final value that I want is 2. So at max I can subtract 7. So first generate all the prime numbers. Okay, generate all the prime numbers, I'll show to you. So this is the maximum amount, this is the maximum value that you can subtract. So now just see which prime number is less than or equal to this, the largest prime number less than equal to this, and then subtract it. So in this case 7 itself is that prime number, so you subtract and you get 2. Okay, now if this number is 2, the smallest possible value that this guy can have is 3. Okay, if this, so initial value of this is 6, the final value I want, the minimum value I want is 6. So at max how much I can subtract? I can subtract 3. So this is the maximum value that I can subtract. So find the largest possible prime number which is strictly less than equal to 3. So you make this guy as 3. Now if this is 3, the smallest possible value that it can have is 4. Okay, so current value is 10, it can have the smallest value as 4. So at max how much can I subtract? I can subtract 6. Okay, I can subtract 6. So what is the largest prime number strictly less than equal to 6? That is 5. So you subtract 5 from here. Okay, once you subtract 5 from here, what do you get? You get 5 here. So 1, 2, 3, 5. Now suppose if I would have had any other element here, like for example 20. Okay, so if this is 5, the smallest possible value this guy can have is 6. So 20 minus 6, that is 14. At max you can subtract is 14. So what is the largest prime number that is less than equal to 14? That is 13. So subtract 13 and you get 7. So 1, 2, 3, 5, 7. This is the logic that we'll be using. Okay, this is the exact logic that we'll be using. So let me show you the implementation. Right, it's a greedy approach, simple. So let me come to the main function now. Okay, so this is my main function, and the first thing that I'm doing is generating primes. Okay, what does this function do? So this is the function generate primes. It simply generates all the prime numbers less than 1000, okay, and add it into this list. Adds those into this list. Okay, you can see this because the value, the nums can have a particular value of nums can be at max 1000. So that's why. Okay, so this basically checks whether it's a prime number or not. Okay, so I could have used sieve algorithm as well, but again that is not needed here. The constraints are low. Okay, so this total code, what it is doing is generating all the prime numbers that I need for my solution. Okay, so I've generated all the prime numbers. This is the number of count of elements that I have. Previous is 0. Okay, why this value is used, I'll just tell you. This value is basically telling me that, okay, I erased it. This value is basically telling me that this will be helpful in telling me what is the minimum value the current element can have. Okay, let me show you. I start a loop. What is my diff? Diff is the current number minus the previous number minus 1. It means that suppose that the current element is 10, okay, and the previous element was 3. Okay, so what is the minimum value this guy can have? It is 10 minus 3. Okay, 10 minus 3 plus 1, that is 7, right? 8, sorry. Yeah, so if no, it should not come like this. If this is 3, the minimum value that this guy can have is 4, right? Now how do we get it? It is 10 minus 3. Okay, 10 minus 3. At max, how much you can subtract? That is what we need to find. At max, how much you can subtract? So you can, if you want to convert this 10 into 4, you can subtract at max 6. Okay, so how do you get it? 10 minus 3 is 7 minus 1, because the diff between these two is 7. But if I subtract 7, then these two values will become 1. So I can at max subtract 6. So this is what I am doing. The current value minus previous minus 1. Current value is 10. Okay, current value is 10. Okay, by mistake I wrote plus 1. That's why. Previous value is 3 minus 1. That comes out to be 6. So at max you can subtract 6. Okay, so that's the logic that I have used here. Okay, now after you know what is the maximum diff that you can bear to subtract, what you will do? I've written a utility function floor prime. So again, this base, what it does, it takes a value, okay, and it returns you the largest prime number that is strictly less than or equal to this diff. Okay, so just see again what I've done. Again, a brute force. If it is if the first number itself is greater than x, you return 0, right? Otherwise, what you do? You just traverse your array and check for the largest prime number that is less than or equal to the given value. Okay, so once I get it, I call it floor. So I subtract this particular value from my current element. That is what we have been doing. I subtract it, and now this value becomes my previous, because this will be used in next step. Okay, how? Because this was 3, this was 10. Okay, I can subtract 7, but I'll subtract 5, right? So this guy becomes 5. Now this 5 will be used in the next step. Suppose the next value is 20. So this 5, so this will become previous now. Okay, that is what we are doing. Finally, when you do all this, you try to make it a strictly increasing array. Okay, after you do this, you finally check that is my array strictly increasing. So you just traverse and you check if this condition fails. That means if the ith element is greater than or equal to I plus 1th element, then my condition fails, you return false, or else you return true. Okay, that's what we are doing. So the main approach, the main observation that we can see here is you need to use a greedy approach where whichever element you are at, okay, try to make it as small as possible. Okay, taking into consideration that it doesn't become smaller than the previous element. Okay, so that's what we are doing. So yeah, I hope you like the solution. Do support it by giving a thumbs up. Do subscribe to the channel as well. In case of any queries, mention that into the comment section. I'll revert on each one of them. Also, I'm attaching the link to the solution in the comment section, in the description. Okay, thank you, take care, bye bye.